Students, in the last session we discussed how to factorize the quadratic polynomials. Yes, in this class we are going to study factorize the cubic polynomials. How to find the factors of a given cubic polynomial. The given example problem is a cubic polynomial in one variable y cube plus 6y square plus 11y plus 6. We need to factorize this expression by the factor theorem. So, we need to find the value of y at which the polynomial becomes 0. So, how to find? By hit and trial method. Let us check for y is equal to 1. Y is equal to 1. Check whether y is equal to 1, it gives 0 or not. You already studied 0 of a polynomial. By substituting 1, is possible to get the answer as 0? Wait a second. Substitute 1 in this expression or in place of y. All the signs of different terms are positive. Is possible to get 0 as the answer? It's impossible. So, y is equal to 1 will never give a 0. So, y is equal to 1 is not a 0 of this polynomial. Let us check for y is equal to minus 1. Y is equal to minus 1. The polynomial y cube plus 6y square plus 11y plus 6 is denoted as p of y, because y is the variable in this polynomial. So, we can write the polynomial p of y. P of y is equal to y cube plus 6y square plus 11y plus 6. Now, substitute y is equal to 1 in place of y, or we can say p of minus 1. P of minus 1, so minus 1 whole cube plus 6 into minus 1 whole square plus 11 into y is equal to minus 1 plus 6. Simplify. Minus 1 whole cube is equal to minus 1 plus minus 1 whole square is equal to 1. 1 into 6, 6. Next, plus into minus, minus 11 into 1, 11. Then the last plus 6. Collect the positive terms, plus 6 plus 6 plus 12. Collect the negative term, minus 1 minus 11 minus 12. So, what is the answer? Answer is equal to 0. It means that if you substitute minus 1 in this polynomial or cubic polynomial, we get p of minus 1 is equal to 0. So, we got p of minus 1 is equal to 0. We have studied factor theorem. The theorem says that if p of a is equal to 0, then x minus a is a factor. If p of minus a is equal to 0, x plus a is a factor. Now, in this example, we got p of minus 1 is equal to 0. So, we say that y plus 1 is a factor. Y plus 1 is a factor. So, y plus 1 is a factor of p of y. P of y is the cubic polynomial. So, we can write the polynomial p of y is equal to, we already got y plus 1 is a factor. So, we can write p of y is equal to y plus 1 into something. Yes, the unknown factor, we should find the unknown factor. The other factors we should find. So, how to find the other factor? There are two methods. First method, by hit and trial method, by substituting different factors of this 6 we can find other factors. Or one more method we have, write y plus 1 3 times in a row. Why 3 times? Because the polynomial is cubic polynomial. There are 3 roots for a cubic polynomial. So we have written y plus 1 3 times in a row. Now, P of y is equal to y cube. This is the first term of this cubic polynomial. By using this expression, how can we find the y cube? Yes, by multiplying y square. To this expression y plus 1, y square into y is equal to y cube, y square into plus 1 y square. Y cube is the first term. What about the second term of this cubic polynomial? 6y square. Just observe here, we have y square, we need 5y square more. So how to get 5y square? Let us consider the second expression, that is y plus 1. How to get 5y square more from this expression? We already have y here, so by multiplying plus 5y. Is possible? Yes, let us check. Plus 5y into y is equal to 5y square. Y plus 1 is a binomial and 5y is a monomial. So the monomial into binomial multiplication we have here. Now, multiply plus 5y into 1 gives plus 5y. Y cube, y square plus 5y square, 6y square. Next, third term is 11y. But we have already here 5y. We need 6y more. So how to get 6y more from this expression? In the last term, we already have y. By multiplying 6 to this expression, plus 6 into y is equal to 6y, plus 6 into plus 1 is equal to 6. Now see, y cube, y square plus 5y square, which gives 6y square, 5y plus 6y, which gives 11y. So the last 6 here, we have 6 here. So we can write P of y, the cubic polynomial, in this form also. In this expression, y plus 1, y plus 1, y plus 1 is a common term. So take out y plus 1 as a common term. Y square, by dividing y square into y plus 1, we get y square. Because y plus 1 is a common term, we have taken out. Then in this 5y into y plus 1 remain 5y, because y plus 1 is a common factor. Then in this term plus 6 into y plus 1 is a common, so remain plus 6. So we got the unknown term as a quadratic polynomial, that is y square plus 5y plus 6. We already studied how to factorize the quadratic polynomial. Yes, by splitting the middle term, or we can use factor theorem once again. We can find the factors of quadratic polynomial by splitting middle term. So the quadratic polynomial q of y is equal to y square plus 5y plus 6. What are the steps involved in the factorization of quadratic polynomial? Yes, the first step is find the product of the first and last term. What is the product of first and last? That is 6y square. 6y square. Next step, yes, list out the possible factors of this 6y square. We have 1 and 6. 1 and 6 are the factors of 6, or 1y and 6y are the factors of 6y square. But the condition is, if you take p is equal to 1y, q is equal to 6y, but the sum here 5y. If you add 1y, 6y, we get 7y. Is possible to get 5y from 1y and 6y? No, it's impossible. So the first factors are rejected. Then one more we have, factors of 6, p is equal to 2y and q is equal to 3y. What about these two factors? The product is 2y into 3y is equal to 6y square. What about the sum p plus q? P plus q is equal to 2y into 3y is equal to 5y. So we got the sum p plus q is equal to 5y. We have 5y as a middle term of this quadratic polynomial. So we can write, or we can split 5y as 2y and 3y is equal to y square plus 5y can be written as 2y plus 3y, and the last is 6. Next grouping, y square plus 2y is the first group, 3y and 6 are the second group. Y is the common term in both, so take out y plus 2 is remain, or y into y, y square, y into 2, 2y. Then plus 3y plus 6. What is the common factor? 3 is a common. So take out 3 as a common term. So we can write 3 into y, 3y. 3 into 2 is equal to 6. Y plus 2 are common again. Take y plus 2 out and write y plus 3. So we got, there are two factors for a quadratic polynomial, y plus 2 and y plus 3. So we can write the polynomial p of y is equal to y plus 1 into y plus 2 into y plus 3. So we can say p of y is equal to y plus 1 into y plus 2 into y plus 3. These are the three factors of a given polynomial p of y, y cube plus 6y square plus 11y plus 6. Second problem, factorize the cubic polynomial x cube minus 2x square minus x plus 2. Cubic polynomial in one variable x. So we can write p of x is equal to x cube minus 2x square minus x plus 2. We need to factorize this cubic polynomial by the factor theorem. So we need to find the 0 of this polynomial first. So how to find? Yes, by trial and error method. Let us check for x is equal to 1. If x is equal to 1, p of 1 is equal to, because x is equal to 1, p of 1 is equal to, substitute 1 in this polynomial. So we get 1 cube minus 2 into 1 square minus x is equal to 1 and plus 2. Then simplify, 1 cube is equal to 1 minus 1 square is equal to 1. 1 into minus 2 gives minus 2 and minus 1 here plus 2. Collect the positive terms, plus 1 plus 2 is equal to plus 3, minus 2 minus 1 is equal to minus 3. After the simplification, we get P of 1 is equal to 0. What do you mean by P of 1 is equal to 0? If P of 1 is equal to 0, then x minus 1 is a factor of P of x. If P of 1 is equal to 0, x minus 1 is a factor. So, we got x minus 1 is a first factor or one of the factor. The polynomial is cubic polynomial. We know that there are 3 factors. We already have one factor. So, how to get other? We can write P of x is equal to x minus 1 into something. Here also the same steps. We can write x minus 1 3 times in a row. Why 3 times? Yes, the polynomial is cubic polynomial. So, we have 3x minus 1. 3 terms x minus 1. P of x is equal to x minus 1, x minus 1, x minus 1. Then, the first term of this cubic polynomial is equal to x cube. How to get x cube from this expression? We already have x here by multiplying x square into x cube, x square into minus 1, that is x square. The second term of the polynomial is 2x square. We already have minus x square. If you substitute minus 2x in this expression, we get minus 2x square as a product. So, what will happen? Minus x square minus 2x square. The sum is minus 3x square, but we have minus 2x square only. So, how to get the factor? Yes, by multiplying minus x. So, minus into plus minus x into x square. Then, minus x into minus 1 is equal to plus x. In this expression, we already have minus x, but the answer is, after the simplification, we got plus x. So, how to get minus x? Yes, by multiplying minus 2. If you multiply plus 2 into x plus 2x, after the multiplication, we get plus 2x here. The sum is 3x, but we have minus x here. So, we are multiplying with the minus 2. Minus 2 into x is equal to minus 2x, minus 2 into minus 1, that is plus 2. Let us check. Minus x cube, minus x cube, minus x square, minus 2x square, plus x minus 2x, the sum is minus x. We have 2 here, 2 here. So, we can write P of x in this form also. By observing this term, we can say x minus 1 is a common factor. So, take out x minus 1 as a common factor. In this first term, x minus 1 is a common. So, what remain? X square. What about the second set? Yes, x minus 1 is a common. So, remain minus x only. In this last, x minus 1 is a common. So, minus 2 remain. So, we can write P of x in this form also. So, the unknown factor we got x square minus x minus 2. X square minus x minus 2 is a quadratic polynomial. We already studied how to factorize the quadratic polynomial. by splitting middle terms or by substituting the factors or 10 trial method. So, we are using here splitting by middle term. So, let us consider the quadratic polynomial in one variable x is qx, x square minus x minus 2. What are the steps in the factorization of quadratic polynomial? Yes, first we should find the product of first and last term, that is 2x square with the negative minus 2x square. Then we have to find the possible factors of minus 2. The one and only factors, set of factors are 2 and 1. But we need minus x as a middle term of this quadratic polynomial. So, how to get minus from these two factors? We need to put a minus sign to the first factor 2 and the positive with the second factor 1. So, by multiplying these two factors, we get minus 2x square, because minus into plus is equal to minus, 2 into 1 is equal to 2 and x into x is equal to x square. But what about the sum? The middle term is minus x here. P plus q is equal to minus 2x plus x. Answer is minus x. So, these are the two factors which gives the product minus 2x square, at the same time the sum minus x. So, write x square minus x is equal to minus x plus x minus 2x and minus 2. Minus x is equal to plus x and minus x. Next, grouping the terms x square plus x. In these two terms, x is common. X is a common term. X square by x is equal to x, or x into x is equal to x square. X by x is equal to 1, or x into 1 is equal to x. Then consider third and fourth term. What is the common factor here? Minus 2 minus 2. There is no common variable, we have constant only. So, write minus 2 as a common factor, take out minus 2x by minus 2 is equal to x, or we can say minus 2 into x is equal to minus 2x. Minus 2 by minus 2 is equal to plus 1. Again, x plus 1, common factor, take out x plus 1 as a common factor, remain x minus 2 only, x minus 2. So, these are the two factors of this quadratic polynomial. Finally, what are the factors of this cubic polynomial? We already got x minus 1 as a factor and x plus 1, x minus 2 are the other factors. So, we can write P of x is equal to x minus 1, x plus 1 and this x minus 2, or we can say x minus 1, x plus 1 and x minus 2 are the three factors of a cubic polynomial. Okay students, we will stop here and continue in the next class. Thank you.